video we're going to introduce and just start to use the Arrhenius equation. So remember that the Arrhenius equation is going to link the rate constant K to the temperature T in Kelvin. And the Arrhenius equation goes like this: the rate constant K equals A, which is a constant, times the exponential function to the power minus EA over RT. So let's just remind ourselves what all these units are. So K is the rate constant, and A is the Arrhenius constant. Now what we can say about these two is that their units are going to be the same. And the units of this we're going to determine from the rate equation. The units depend on the orders, but whatever we get for K, we will have the same units for A. So we learned how to work out units of K earlier on, and once we know the units of K, we know the units of A. If we're given the units of A in the question, we've got the units of K. We know that EA is the activation energy. Now normally activation energy is given to us in kilojoules per mole, but for this equation it has to be in joules per mole. So we're going to need to convert and then we've got R, which is our gas constant. That will always be given to us. Remember that it equals 8.31 or 8.314, and this is the reason why activation energy has to be converted, because this is in joules per Kelvin per mole. So this is in joules per mole, so activation energy needs to be in the comparable units, joules per mole. And T is temperature, and we know that that temperature is going to be in Kelvin because we've got our R in joules per Kelvin per mole. Now what is this exponential? Let's just have a quick look at a calculator. Here's a calculator. This exponential function is found just above the natural log button here. You can see there. So you find that on your calculator by pressing the shift and then the LN button, and you will get this e to the button. Okay, so this function, the exponential function. So that is our exponential. So we can see down here that the units, we've got that little star box to remind us about that conversion and how you would convert from kilojoules to joules by multiplying by 10 to the 3, multiply by 1,000. So let's have a go with that. Let's put the numbers in. So remember that the equation goes K equals A e to the minus EA over RT, and we've got to watch out for those unit conversions. So we know that A is just there, 1.0 times 10 to the 14. Then we're going to have this exponential function, e, to the minus EA, 75, but we need to convert that into joules per mole over the gas constant, 8.314, times the temperature. Now we've been given the temperature, but it's not in the right units. So how do we convert 27 degrees C into Kelvin? And for temperature, it's not a times by 10 to the 3 thing. Add 273. So we're going to get our two converted things. So this is convert to joules per mole by timesing by 10 to the 3, and this was converted to Kelvin. Right, so how are we going to put that into our calculator? So let's bring back our calculator and have a look. So here's our calculator. So we're going to type in the numbers exactly as we've written them. So 1.0 times 10 to the 14. Then to get that exponential in, remember we're going to press shift and then the LN button. There we go. We're going to use the fraction because it's got this fraction, our exponential. We've got minus 75, converting it to joules times 10 to the 3. Going down to the bottom line, 8.314 times 300. And it's giving us a value of 8.727. Now bearing in mind that we've been given EA and A to two significant figures, I'm just going to give my answer to 2. Then I think, what units does this have? Because I might be asked. And we remember that it has to have the same units as A. So I want you to pause the video and see if you can repeat that with this new temperature of 37 degrees C. So I've converted my EA and my temperature, so let's just put those onto our calculator screen. So remember we've got 1.0 times 10 to the 14, shift ln to get the exponential, use the fraction button, put our activation energy, remember don't forget that minus sign, go down to the bottom line, 8.314, this time we've got 310 Kelvin, and press the equals button. And we're getting an answer of 23 seconds to the minus 1. So what was the effect? How much of a difference did it make when we increased the temperature by 10 degrees C? So if we have a look, we went from 8.7 to 23, so that's an increase of 2.6. So we can just move the calculator out there. You can see that increasing the temperature by 10 degrees C increased the rate constant, or the rate, by over 2 times. So let's have a look at another example. This time we're trying to work out the value of the Arrhenius constant A. So let's just remind ourselves that the equation goes K equals A e to the minus EA over RT. By the way, they're always going to give you this equation in the exam. You will not be expected to memorise this equation. You just need to be able to use it confidently. So this time we're going to put our numbers in. We've got K is 400. We don't know what A is, but we do know that EA is 120, but we remember we have to convert that. We've got the R, 8.314, and we've got the temperature T. So what is 25 degrees C? That's 298. So what I would suggest you do on this one is I would suggest you work out what this exponential function is before you take it over to the other side. So actually calculate the value of that exponential function. So to do that, we're going to bring back our calculator. We're going to actually calculate this. So we're going to go shift log, put in the fraction, put the minus sign in. We've got 120 kilojoules per mole, but we're going to convert to joules per mole. And we're going to divide by 8.314 times 298. Okay, so I'm going to leave that on my calculator now and just have 400 equals 9.23 times 10 to the minus 22 times A. So A equals 400 divided by 9.23 times 10 to the minus 22, which equals, so we're going to have a look at what that equals. So how would you rearrange that on your calculator? Oops, I've just lost my calculator. Let's just bring it back in. There we go. So I'm going to keep that number there in the display. So I'm just going to use the fraction button. I'm going to press 400 on the top. I'm going to go down to the bottom line, and I'm going to press answer. That will bring back that answer I just had. And there you go. You can see I've got 4.33 times 10 to the 23. Now, what units will this have? This is the value for A. What units will it have? And it will have the exact same units as K, because K and A always do. And if I looked at this, I could tell you that this was an equation that was overall second order from those units, because we've had experience of using those units before. So there we go. Moles to the minus 1, dm cubed seconds to the minus 1. So that's our first video on using the Arrhenius equation.